All right, in this video we're going to look at solving quadratic inequalities. And I really want to talk about some ideas that really would work with any kind of inequalities, but especially are important for ones like this. So when you think about working with equations, if I had an equal sign here, you have lots of tools for solving equations. And sometimes students try to apply those to inequalities as well. So sometimes students might think about just taking the square root of both sides of something like this. But unfortunately, that doesn't work. You have to be more careful with inequalities than you do with equations in terms of making sure that you don't violate the truth of the statement so that it doesn't change the direction of the inequality. So this strategy will work anytime you're working with inequalities where you're not really sure that what you're going to try to do is to both sides is going to preserve the inequality. So what you can think about, instead of thinking about x squared being less than 12, you can start by considering the easier problem, set x squared equal to 12, and then work with the problem like that, and then we'll come back and think about the inequality here. So you're essentially just replacing the inequality with equals just to give you some more mathematical tools to work with. All right, so this is pretty straightforward to solve. Most students in calculus remember how to do this. You can just take the square root of both sides. You do have to remember some plus or minus on this side, because when you square negatives, that also would work, right? So when I square negative numbers, I can get a positive also. So when I square root both sides here, I'll get x is equal to plus or minus the square root of 12. And since the square root of 12 isn't a perfect square root, you can either leave it like that or you can simplify it. 12 breaks down into 4 times 3. So when I simplify this, square root of 4 is 2. So plus or minus 2 square root of 3. And you can get decimal approximations for that as well. Square root of 3 is about 1.7. So 2 times 1.7, this is about plus or minus 3.4 approximately. But these would be the exact values. All right, so this isn't really the problem I was working on, though. I was working on this inequality. But these values I can use as what are called split points, and I can think about a number line. And so I'm just going to put on the number line these two values that would be the split point. So plus or minus square root of 12, or I'll just use the 2 square root of 3 form. And when you're thinking about a number line, that'll also help you when you want to graph the solution to the inequality or write your answer in interval notation. All right, so I just want to make sure I put the numbers on the number line in the right order. So the negative one is going to be first on the left side here, and the positive one will be on the right side. And I mentioned that these are called split points because they basically split the entire number line from negative infinity to infinity up into sections. So I really have 3 sections here. And what I'm going to do is just test values in each of those 3 sections to see if it makes the original inequality true or false. So remembering that this was about 3.4, so if I think about a number that is bigger than 2 square root of 3, so testing a number like, say, 4, when I think about plugging 4 into the original inequality and seeing if it makes that true, 4 squared is less than 12, that's false. 4 squared is 16, which is not less than 12, so that's false. So this is the region of numbers over here that are not going to work for this inequality. And then I want to just test my other 2 regions as well. There are other ways to solve these inequalities, by the way, but I just wanted to mention this as a strategy because we'll use this for some other things actually later this semester as well. All right, so testing a number in between. So negative 2 square root of 3 and positive 2 square root of 3, the easiest number to use that's in between those is 0. So if I want to test a number in between like 0, putting that into the original inequality, that does work, that's true. So this region is yes. All numbers in this region between negative 2 square root of 3 and positive 2 square root of 3 should make this inequality true. And then numbers left of negative 2 square root of 3, so like negative 4, and be careful when you square, so negative 4 squared is positive 16, and so this is a false statement. So this region is not part of the solution. So I've just replaced the inequality with equals, used my tools to get split points, and then I'm just testing intervals here. And this will work with lots of different kinds of inequalities, with fractions, with polynomial functions, exponential functions, all different kinds of things. If you're not sure whether what you might do to both sides of the inequality would work. All right, so at this point, though, I've determined where my solution is. It's this region that's in here between negative 2 square root of 3 and positive 2 square root of 3. And since the original inequality does not involve equals, I don't want to include those endpoints. So just this region in here. So the solution for this inequality here would be the interval from, I'm just going to use interval notation, but you could certainly write your answer in different ways. So the interval from negative 2 square root of 3 to positive 2 square root of 3 is the solution interval. Or if you want to write that in inequality notation, you could say x is between negative 2 square root of 3 and positive 2 square root of 3. So depending on which kind of notation you want to put your answer in. Okay, so let's look at another one, and we're just going to use similar strategy on this one. It's just a tiny bit more complicated because I have x squared being between two values here. And I also have or equal to on both of these. So I just wanted to do one more example to kind of point that out. All right, so we're going to start again by just considering what if these things are equal. So I'm going to split this really into two separate inequalities, or two separate parts. So I'm going to consider when 4 is equal to x squared, and think about what that tells me. So that will give me x is equal to plus or minus square root of 4, which is 2. And then I'm also going to consider when x squared is equal to 8. So solving that for x, I will get x is equal to plus or minus square root of 8, which is 2 square root of 2 if I simplify that. Okay, so here I have 4 split points, and so that's part of how this one is a little bit more complicated, but I'm going to do basically the same strategy I did before, just put all these split points on my number line. So you want to think a little bit about where they go. You don't necessarily need a calculator, it's perfect approximations, just thinking a little bit about, well, 2 times square root of 2 is bigger than 2, right? So even if you don't know that that's about 2.8, square root of 2 is about 1.4, so 2 times 1.4, about 2.8. You know it's bigger than 2. So of these 4 numbers that I have here, 2 square root of 2 is going to be the biggest one, positive 2 square root of 2. And then positive 2 will be less than that. And then on the negative side of the number line, it's just basically a mirror image of this, right? So negative 2 and negative 2 square root of 2. Okay, so these are my split points. So for this one, I have 1, 2, 3, 4, 5 regions that I need to test in the original inequality to see if they make the inequality true. All right, so once you've done some of these, maybe you can do a lot of this calculation in your head. I wrote some things down over here. I don't normally write that down. I'm going to write that on some of these here just to make sure that you're clear about what I'm doing. But for calculus students, just reviewing a little bit of algebra, it's perfectly fine to do a lot of the calculations in your head. All right, so again, I'm going to pick a number that is bigger than 2 square root of 2. So I don't know, 5, whatever. Pick a number that you like that you are sure is over here. That's easy to do mentally in your head. And when I put in 5 to the original inequality, 5 squared is 25. And so that makes this region false. This region is not part of the solution. This region here is a little bit harder to think about. 2 square root of 2, I mentioned, is about 2.8. So I need to think about a number that is between 2 and 2 square root of 2. So maybe like 2.1, 2.5, something like that. So I'm going to go ahead and write some stuff down here when I plug in a number between, like 2.1. So I just want to see if the original inequality would be true when I plug in that number that's in this interval. And you don't need a calculator to think about that, right? 2.1 squared, that's going to be a little bit bigger than 4. 2 squared is 4. This is going to be a little bit bigger than 4, but it's not going to be 8, right? So this one is true. So this region is part of our solution, so we will keep that. Between negative 2 and 2, I could use 0 again. And you can see here when you plug in x equals 0, I have 4 is less than or equal to 0 squared is 0, less than or equal to 8. This region will be false, so this is not part of our solution. And then, because negative numbers, when you square them, act like they're opposites, they're positive numbers, maybe you can think a little bit about what would happen over here without actually having to do a bunch of calculations. But if you need calculations, that's perfectly fine as well. So if I use, say, negative 2.1, again, remembering that when you square, it's going to make the result positive, and so that'll still be true. So this one is yes. And then over here, so say negative 5 or whatever, will also be false like that. Okay, so I have just tested some numbers here and determined where my intervals are that make this inequality true. And then I need to pay a little bit of attention to these inequalities. These both include equals. So if I was going to graph the solution on the number line, I would use either filled in dots or brackets to indicate my solution interval. I didn't graph the last one here, but let's go ahead and shade the regions here on the number line that are solutions. So these would be filled in endpoints. On the last one, that would be open circle on the previous one. So there, if I want to graph the solution, there's my two intervals. And then I'm going to go ahead and write my answers in interval notation. So in interval notation, this one, I need the brackets for the closed endpoints here for including the endpoints. I'll have a -2 square root of 2 to -2 is this interval. And then this interval over here is 2 to 2 square root of 2. And you can put whatever in between here. A comma is okay. Technically, the correct mathematical symbol there is union, that both of these two intervals are solution. Sometimes in the online homework, they'll ask you to use that symbol correctly. If it's written homework, I don't care so much. You can just put a comma or just list both of the intervals. All right, there are certainly other ways to solve these kinds of inequalities. You might think about these in particular as quadratic functions, right? So you might think about parabolas and graphs of parabolas in order to help you determine these solutions. So there are a lot of different ways. And as calculus students that are just leveraging algebra as needed, I want to encourage you to use those other ways if they come to mind. But I just wanted to point out this method because we will use this for some other things, and it seems to be a method that a lot of students like and find pretty easy to remember when they're trying to remember this later in the semester when we need to deal with some inequalities that we don't always deal with that often. All right, try some practice problems.